Right now, floating about 1 million miles away from your home, a telescope the size of a tennis court is staring into the deepest dark we have ever seen, and it keeps finding things that, by every rule we have ever written down about how the universe works, should not be there. If one of those things were sitting in our own solar system, you would have to rewrite every science textbook on Earth by the end of the week. By the end of this video, the story you have been told about how the universe was born is going to look smaller than it did when you woke up this morning, and the word impossible is going to feel like a place, not a word. Let us start with what most people think they already know, because what most people think they know is the problem. For the last 30 years, the standard story of the universe has gone something like this. About 13.8 billion years ago, everything that exists was squeezed into a point smaller than a marble. Then it exploded outward. For the first 300,000 years, the universe was so hot and so bright that there was no such thing as an atom. There was just a fog of energy and tiny particles bouncing around in the dark. Then the fog cooled. The first atoms formed, mostly hydrogen, a little helium, almost nothing else. Those atoms slowly, over hundreds of millions of years, started to gather. They gathered into the first stars. Those first stars died in huge explosions. Their ashes made the next generation of stars. Those new stars made more ashes. The ashes built planets and galaxies, and eventually, after an absurdly long chain of accidents, you. That is the old story. That is the one in the textbook. And for most of my life, it felt safe. Now the telescope has come back from the dark with photographic evidence that says parts of that story are wrong. Not unclear, not a little fuzzy, wrong. The telescope I am talking about is called the James Webb Space Telescope, although everyone just calls it Webb. It was launched on Christmas Day 2021, after more than 2 decades of planning and more than $10 billion of engineering. It is parked about 1 million miles from Earth, in a part of space where the gravity of the sun and the Earth balance in just the right way so the telescope can hover there, like a leaf caught in a stream, and not run out of fuel for tens of thousands of years. It floats behind a sunshield the size of a tennis court, an umbrella made of 5 layers of plastic so thin you could see through a stack of them with your hand. And that umbrella keeps the cold side of the telescope colder than the surface of Pluto. The cold is not a luxury. It is how the telescope can see the faintest, oldest light in the universe. Any warmth at all, even the warmth from the telescope's own electronics, would smear the picture into noise. So Webb lives in deep cold year after year and watches the sky through the largest mirror ever sent into space. That mirror is made of 18 golden hexagonal tiles that unfold like petals in space. Each tile is beryllium, the lightest metal strong enough to hold its shape in deep cold, and it is coated in about a teaspoon of pure gold to reflect infrared light. Together, those 18 petals act as one giant eye, 6.5 meters across, tuned to see colors of light our eyes cannot see. And those colors, those invisible colors, are the colors of the very first stars and the very first galaxies, because the universe has been stretching for 13 billion years, and stretching pulls light toward the red, beyond red, into the infrared. To see the beginning of everything, you have to see the same kind of light that your TV remote uses to change the channel. Webb began returning science in the summer of 2022, and within months it started making scientists nervous. The first big surprise came in the form of impossible galaxies, galaxies that were too big, too bright, too old. Let us pick one in particular, because it is the cleanest example and because we are going to come back to it several times in this story. Astronomers working on a survey called JADES, using Webb's near-infrared camera, found a small smudge of light in one of their deep field images. They did not pay much attention to it at first. It looked like an ordinary fuzzy dot, one of thousands of fuzzy dots in any deep sky picture. They took its spectrum, which in astronomy means they spread its light into a rainbow and read the chemical fingerprints inside it, and the result made the lead researcher, according to people who were there, lean back in her chair and say, "This cannot be right." The smear of light they had picked up was being seen as it was when the universe was only about 290 million years old. For context, 290 million years is about 2% of the age of the universe. It is the fraction of a single second, if the entire history of the cosmos were a year long. And the light from that smear had been traveling toward us for 13.4 billion years to land on Webb's mirror. The object is called JADES GS Z14.0. The number 14.32 is its redshift, which is just a fancy way of saying how stretched the light was on its way to us. A higher redshift means farther away, farther back in time. The previous record for the most distant galaxy was around redshift 13. This new one was at 14.32. It jumped the line by a huge step. But the redshift was not the only thing that made the room quiet. The galaxy was also bright, much brighter than it should have been for being so young. To make that much light that early, the galaxy would have needed to be making stars at a furious rate, hundreds of times faster than our own Milky Way is making stars today, far more than the old models said anything had time to do in 290 million years. Or it would need to be much bigger than the old model said, packed with stars, doing work that should take billions of years to finish. Either answer is uncomfortable. Both answers together are borderline embarrassing. Imagine walking into a kindergarten classroom and finding that one of the children has just written a novel. That is roughly the level of weird we are talking about. Now, this is the part of the story where you have to be careful, because scientists themselves are still being careful. Some of the early excitement about impossibly early galaxies faded when researchers looked at the numbers more closely. A few of the brightness estimates were scaled down. A few of the galaxies turned out, on closer inspection, to be slightly closer in time than originally claimed. That is how good science works. You announce something strange, you check it, you scale it, and either it stays strange or it does not. But here is what did not fade. JWST kept finding more of them, and not just one. Wave after wave after wave. Surveys from multiple teams using different cameras in different parts of the sky kept producing early universe galaxies that looked far more mature, far more massive, far more chemically enriched than any model said they should. Take one called MOEMZ14, found in 2025, also pushing the redshift record, also shining much brighter than expected for its age. Take the galaxies in a survey that found more than a dozen bright early galaxies where the old models expected only one or two. Take the so-called little red dots, hundreds of them, compact, intensely red galaxies that appeared all over the early sky, packed so tightly that they looked almost like the seeds of the modern universe, but appearing so soon after the Big Bang that, again by the old rules, they should not have had time to form yet. And this is where the mystery becomes more than just a curiosity about galaxies. Because galaxies are not the only things that should not be there yet. Black holes are showing up where they should not be either. Quasars, the most violent objects we know how to see. Let us slow down here, because quasars are worth knowing about. A quasar is what you get when a supermassive black hole at the center of a young galaxy is being fed by huge amounts of gas and dust. As the material spirals inward, before it crosses the event horizon, it gets crushed and heated to millions of degrees. It glows brighter than an entire galaxy of stars, outshining everything around it, sometimes by factors of 1,000. From far away, a quasar looks like an absurdly bright pinprick of light, a beacon, a lighthouse from the early universe. Astronomers have known about quasars for decades. The mystery is how they got started so fast. Webb has now found quasars from when the universe was only a few 100 million years old. One of them, captured in detail, has a black hole inside it that weighs roughly as much as several 100 million suns. Another, even earlier, was eating less than expected, almost politely, which made the problem weirder. The old idea was that these monsters had to start as small black holes, born from the collapse of the first big stars, and then grow by swallowing gas and merging with other black holes over billions of years. That growth takes time, a lot of time. But Webb is showing us quasars that look like they have already finished the growth stage, even though the universe has barely started. The math does not add up. There is not, in the early universe, enough food around, enough time, enough mergers to build a black hole that big that fast with the models we have. That is the real heart of this story. Galaxies that look too grown up, black holes that look too heavy, stars that look too rich in heavy elements for being so young. Each one of those things, on its own, would be a puzzle. Put them together, and the puzzle starts to feel less like a series of small errors and more like a sign that we have been missing something fundamental about the early universe. Now, let us not pretend this is settled. It is not. There are several serious explanations on the table, and a few of them could turn out to be true at the same time. The first possibility is the cautious one. Maybe our estimates of how massive these early galaxies are have been off. Maybe what we are seeing as 100 billion suns of starlight is actually closer to a few billion, and the early universe is not as mature as it looks. This is what a lot of careful researchers are now arguing in published papers. They point out that the brightness of a galaxy is not the same as its mass. A small galaxy can look bright if its stars are young and hot. A galaxy can look bright if it is being magnified by the gravity of a foreground galaxy cluster, a trick of the universe that fattens its image on our telescopes. The early galaxies that Webb has found are real. How heavy they really are is still being measured, and the new measurements are slowly, carefully shrinking the surprise. That is good, that is honest, that is the part of science most people never see. The second possibility is more interesting and a little unsettling. Maybe the early universe was simply more efficient at making stars than we thought. Maybe the first generation of stars was different in some important way. Maybe they were cooler and more gigantic than the stars we know, what some astronomers call dark stars, objects so huge and so cool that they do not look like normal stars at all, objects that could pump out enormous amounts of light without giving off many of the signals we have been looking for. Maybe the early galaxies were not just stars, but seeds of black holes, too, galaxies that already had their monster buried inside, almost from the start. This idea is not science fiction. It is in published papers. Some of the brightest theorists in the field are seriously exploring whether the first luminous objects in the universe were already hybrids, both starlight factories and black hole seedbeds, the way an oak tree is both a leaf and an acorn before you ever see it sprout. The third possibility is the wildest. Maybe the textbook itself is wrong in some basic way. Maybe the speed at which we think the universe has been expanding, the number we call the Hubble constant, is not the right number. Maybe the geometry of the early universe was slightly different from how we have been modeling it. Maybe dark matter, that invisible scaffolding that we have inferred for decades, did not behave the way our models say it should in the first few 100 million years. Maybe the universe in its first breath was warmer, denser, more tangled than we thought, and what we are seeing in Webb's pictures is the real shape of things. And the shape we have been imagining for decades is the cartoon. And here is why this matters, even if you do not care about the technical details. If the early universe was richer, brighter, more structured than we thought, then the conditions that produced us may have been more common than we thought. If galaxies formed fast, then perhaps they form everywhere. And planets are not rare accidents, but routine products of a universe that is good at making real estate for life. If black holes formed fast, then perhaps the energy and chemistry they pour out into their host galaxies, which is more than you would imagine, is part of why those galaxies are so hospitable so early. The beginnings of life may have had more time, more variety, more places to try than our old models suggested. We are not there yet. We cannot say that. But the door that Webb is prying open points in that direction. And that brings us to the part most videos about space skip, and it is the part I find most worth saying out loud. The thing that Webb found that should not exist is not really a galaxy. It is not really a black hole. It is the quiet assumption that we already knew the shape of the story. For most of my life, the way cosmologists talked about the early universe was the way a museum tour guide talks about a reconstructed village. Everything is in its right place. The timeline is smooth. The proportions feel just right. The first stars flicker on. The first galaxies slowly grow. The first black holes quietly double. And then, billions of years later, after a long and tidy staircase, here we are. The temptation, when you have a story like that, is to treat it as the story. But every major telescope in history has eventually broken some part of the museum. Galileo's little telescope broke the idea that Earth was at the center. Hubble's big telescope broke the idea that the universe was eternal and unchanging. Webb's giant golden mirror, floating in the dark a million miles away, is breaking the idea that we knew how the first chapters of everything went. And that is not bad news. That is what telescopes are for. Now let us pull this back to something smaller, to something personal. Because all of this can stay abstract if you let it. Let us not. You are sitting where you are right now, on a planet with a thin blue atmosphere wrapped around it, in a quiet part of a galaxy that holds about 100 billion stars. You came out of a long chain of accidents. A star had to be the right size to live long enough to give you time. A planet had to be the right distance for liquid water. A moon had to be the right size to stabilize your tilt. A magnetic field had to be the right strength to keep the solar wind off your back. A handful of atoms had to be in the right place at the right moment in a reproducing cell on a young Earth, and then the cell had to survive, and then evolve, and then keep surviving, and then somehow, after 4.5 billion years of mostly bad news, end up with a creature that asks questions like the one we have been asking for the last few minutes. The fact that you exist is, by every honest measure, almost a miracle. If Webb's early galaxies are right, if the universe got busy even earlier than we thought, then something like you is more likely to exist than we used to believe. That is one quiet, possible, beautiful upshot of this whole strange story. But there is another upshot, and this one is harder. The objects Webb is finding are also saying something quieter and more unsettling. The story of how we got here may not be special. It may not be the only way. It may not be the only time. When we look at the early universe and find structures that should not be there yet, we are also looking into a mirror that says, in a voice we were not quite ready to hear, that the universe has had more time, more practice, and possibly more attempts at becoming what we are than we assumed. That does not mean anyone is out there. It means the odds of someone being out there just changed in a direction we cannot ignore. And there is a third upshot, and this one is for you specifically. The next time someone tells you that science has figured out how everything began, smile politely. They mean well. But what they are saying is that we have stopped being surprised. And the moment you stop being surprised is the moment you stop paying attention. The best science is the kind that keeps breaking your own story and asking you to rebuild it, and then breaking it again. Webb is doing that right now. It has been doing it for the last 3 years, and it is not done. So let us give credit where it is due. The James Webb Space Telescope was not built to confirm what we already knew. It was built to test it, and the moment it opened its eye, it began returning pictures that are, in many cases, more beautiful and more unsettling than anyone expected. The cosmic cliffs of the Carina Nebula, the deep field of a single patch of sky no bigger than a grain of sand held at arm's length, packed with thousands of galaxies. The rings of dying stars, the protoplanetary disks around young stars, where, in some cases, the chemistry of water has already been detected in the very places where new worlds are forming. Webb is not just showing us things that should not exist. It is showing us a universe that is busier, weirder, and more generous with its mysteries than the one our parents' generation grew up believing in. And that is why this matters. Because every time a generation thinks it has understood the beginning quietly replies, "Not yet." And the reply does not come from priests or philosophers. It comes from a piece of gold-coated beryllium floating in the dark, returning, in a language made of light, the message that we are still at the very beginning of understanding what is out there. That is not a frightening thought. That is an invitation. If this made you feel a little smaller in the best possible way, leave a comment telling me what you think is hiding in those first pictures we have not decoded yet. Subscribe if you want to keep following these stories with me, because the next time Webb points at a patch of sky that nobody has ever cared about before, it is going to find something else that should not exist. And we are going to have to figure out together what it means that the universe keeps refusing to follow the script we wrote for it. Because in the end, the only thing more surprising than finding something in the dark that should not exist is remembering that we are also made of that dark, and we should not exist either, and yet here we are, asking.